Everybody to Maths by Mars, and in today's lesson we're going to be going over the quotient rule. So what exactly is a quotient rule and when do we use it? Let's say, for example, we have a function f of x, which is made up of a top function u of x divided by a bottom function v of x. The derivative of f of x in this case would be u prime of x multiplied by v of x minus, u of x multiplied by v prime of x. This whole expression would be divided by v of x squared. An easier way to remember this would just be u prime v negative u v prime over v squared. Okay, I want you guys to note this down. So let's go over a basic example real quick. First step you want to take is you want to find your u and your v. In this case, u would be 2x and v would be x plus 1. U prime would be 2 and v prime would be 1. Okay. As we discussed, y prime would be u prime v minus u v prime over v squared. So let's sub everything in. Okay. So y prime would be 2, v would be x plus 1. Let me make the line a little bit longer. Okay. Minus u, which is 2x, and v prime, which is 1, all over x plus 1 squared. So let's simplify now. On top we have, I'm going to use blue, 2x plus 2, then minus 2x. As you can see, x's cancel out, but I'm going to do that in the next step. We can just leave the x plus 1 squared as it is. Okay, so this whole expression would be, remember, x's cancel, it's 2 over x plus 1 squared. Okay? Now we move on to the next example. We do the same thing. U is equal to 3x plus 1. V is equal to x squared. Okay, u prime is equal to 3. And v prime is equal to 2x. So let's write down y prime. We're going to get u prime times v minus u multiplied by v prime over v squared. So let's simplify now. Y prime is equal to 3x squared minus, let's do this a little bit on the side, just so we don't get mixed up. 3x plus 1, 2x. Remember, 3x times 2x, 6x squared. 1 times 2x plus 2x. But there's a negative sign. So, I put the negative up front. We have negative 6x squared, negative 2x. Now you just bring that back. Okay, we have 6x squared minus 2x over x to the 4. So our final answer would be minus 3x squared minus 2x over x to the 4. And you can leave it like that. Okay. For our next example, we have a trig function, but it's the same stuff. U is equal to cosine of x. V is equal to x squared. It's literally the same denominator as the last question. I have v prime is equal to 2x. And as you recall from my trig identities video, I think, or if I haven't released that yet, my bad, I will do that really soon. It would be negative sine of x. Now, y prime is equal to, long line, just in case, negative sine x multiplied by x squared minus, I guess the line wasn't long enough, cosine x 2x over x squared squared. And as usual, simplify. Okay, whenever you have something like this, it's always better to put the x in front of a trig function, okay? It just looks cleaner. There's no mathematical reason to it, I just like it that way. So we have negative x squared sine x minus 2x cosine x over x to the 4. And you can leave it like that. On to the last example. Oh, I didn't write down the last example. Okay. Give me 1 second, guys. This one is honestly the hardest question out of these examples I found. So let's do it. Y is equal to x over the square root of x plus 1. Okay? And as you guys remember, the square root of x plus 1 is basically just x plus 1 to the half. And it's the same process as usual. U is equal to x. V is equal to x plus 1 to the power of a half. U prime is 1. You guys remember the chain rule, which I covered in the last topic? V prime is equal to bring down the power. It's equal to a half x plus 1. Negative a half, because you subtract 1 from the power, multiplied by the derivative of the inside function, which is this one. You can ignore that. No need to complicate things. And as usual, the next step is y prime is equal to, long line this time. I'm trying to be extra cautious. 1 multiplied by x plus 1 to the half minus x multiplied by half. Let's use a different type of bracket. Half x plus 1 to negative half. All over, you guys remember, you have two numbers, two square roots multiplied by each other, you just get the number. They cancel each other out. So, what would square root of x plus 1 squared be? Just simply x plus 1. Okay? That's our first step right there. I'm gonna do this a bit slower because I don't want you guys to miss out on any key details. So, 1, we can just ignore the 1 to the half, minus, I'll bring out the half, minus a half x plus 1 to negative a half over x plus 1. And if you guys notice something, there's a x plus 1 on both sides. Okay? So I'm gonna factor out x plus 1 to the negative a half. Do that. We have x plus 1 to the negative a half multiplied by, oh, what happens over here? You guys gotta tell me. Wait, I'll do it over here, just for the sake of doing it. Multiplied by x plus 1. Let's give it a number. Wait, just to make sure I'm not messing up anything. Gives us x plus 1 to the half. You guys remember how when you multiply two thingies, it's basically the addition of their powers. So negative half plus 1 would give us a half. Okay? Sorry I overcomplicated that. I just wanted to make sure you guys get this step. So it'd just be x plus 1. And as you guys remember, we took out x plus 1 to the negative half, so all we have left is a half x. There we go. Wait, let me space these out. It's better I do it that way. Okay. Over x plus 1. Let me take a look at the next step. Okay. Now we just bring down the x plus 1 to the negative half. It would be, because remember, you bring it down, it turns into x plus 1 to the half. Okay. And the little dot of x plus 1, negative half x. Okay. Now for our final solution. 1x negative a half would be negative x plus 1. Remember, 1 plus a half would be 1.5, which is 3 over 2. It would just be x plus 1 to the 3 over 2. That's our final answer.